Hey everyone, it's Mikki here. You're listening to a mini Mikkipedia on a Monday, and I want to tackle a topic that I get not infrequently, and I guess you could say it's a controversial sort of issue. And I'm going to describe or explain the reasons why and give you my practical considerations and what I think about when I think about a person's ferritin or iron level. So there is an argument for and against having a low ferritin across the board. And it's an argument amongst practitioners. It's not even an argument, it's just a difference of opinion. And so I want to sort of summarize for you why different people have different interpretations. And then, like I say, give you my practical understanding of it. And for what it's worth, I do think that proponents of either having a lower ferritin or a higher ferritin, and by higher, and I'll go through the numbers, but I'm not meaning like super duper high, but I think a lot of this will be governed by the clients and patients that they see, because different practitioners will attract a different kind of patient. So bear that in mind as I go through some of this information. This is a geeky science one, but I know a lot of you are geeky scientists or like the geeky science, so totally down with that. So what I'm going to go through is the summary of the low ferritin hypothesis. It's just basically the evidence supporting low ferritin levels and the potential benefits, but then also go over the counter arguments and the potential cons of the low ferritin hypothesis. So the low ferritin hypothesis proposes that maintaining a low normal iron stores, that's what ferritin is, it's storage iron, roughly a serum ferritin of about 20 to 30 nanograms per milliliter is optimal for health. Now, there's a guy that's often quoted, Dr. Leo Zakarski. Him and his colleagues argue that excessive body iron contributes to chronic disease via oxidative stress and inflammation. They note that ferritin levels of around 25 nanograms per milliliter are typical in children and premenopausal women, whereas adult men and postmenopausal women often accumulate ferritin above 100 nanograms per milliliter. And the children and premenopausal women often have lower heart disease rates. This rise in iron stores with age and sex correlates with an increased risk of myocardial infarction, stroke, and other conditions. The hypothesis posits that keeping ferritin in the low end of the normal range may reduce oxidative damage, thereby lowering the risk of cardiovascular disease, cancer, neurodegeneration, and even certain infections. Proponents liken this to how optimal ranges for cholesterol and blood glucose tighten over time, suggesting that currently accepted normal ferritin, often up to 300, and honestly I've seen it up to 500 on some labs, might actually be higher than ideal. And for what it's worth, I 100% agree that 300, 400, 500, way too high. In summary, the low ferritin theory holds that excess iron is a modifiable risk factor and that periodic iron reduction, i.e. through phlebotomy or blood donation, to maintain ferritin in that 20 to 30 nanograms per milliliter would confer health benefits without causing iron deficiency. So, look, iron is an essential mineral, as you know, but beyond what the body needs, it can become harmful. Free iron readily participates in ferritin chemistry to produce a reactive oxygen species, leading to lipid peroxidation and cellular DNA damage. High iron levels can oxidize LDL cholesterol and promote atherosclerotic plaque formation. And iron excess also triggers a prothrombotic state by activating platelets and can impair endothelial function by scavenging nitric oxide, which is a vasodilator. And what that means is that it will thicken the blood and it will increase your risk of blood clots. Supporters point out that the body has no active way to excrete iron except through blood loss, so iron accumulates with age unless checked. Obviously, you're going to lose it if you're a menstruating woman. They view that the low ferritin range of about 20 to 30 as reflecting an iron replete but not iron excess state is enough for normal physiology, but avoiding the pro-oxidant reservoir of high iron stores. By maintaining ferritin in this lower range, proponents believe one can minimize iron-driven oxidative damage and inflammation over a lifetime. This forms the basis for exploring potential benefits in multiple health domains, from heart disease to brain aging. And so there are several lines of scientific evidence that have been cited to support this low ferritin hypothesis. And I'm not going to go through them all in depth because it would just take too long. But for example, there are epidemiological associations. For what it's worth, some would say it is worth more than others would. Early studies suggest a link between higher iron stores and cardiovascular risk. There's a landmark Finnish cohort called the Copio Heart Study found that middle-aged men with elevated ferritin above 200 had over twice the risk of an acute heart attack compared to those with lower ferritin, even after adjusting for other risk factors. This supports the idea that high normal iron might accelerate coronary disease. Similarly, population studies noted that men tend to develop heart disease earlier than women, and the gap narrows after women's ferritin rises post-menopause. And that hints that iron could partially explain the sex and age differences in heart risk beyond just normal hormonal factors. In fact, Sikarsky points out, that's Dr. Leo Sikarsky, that high ferritin levels have been statistically associated with greater carotid artery thickness, faster atherosclerosis progression, that's just plaque buildup, and worse outcomes after stroke or heart attack in some studies. And habitual blood donors have been observed in some cohorts to have lower cardiovascular event rates. So this is all epidemiology studies, and this is not cause and effect, this is just showing correlation. However, there are clinical trials, and there's one called FEAST. It's the Iron and Atherosclerosis Trial, led by Dr. Sikarsky. So it enrolled over 1,200 patients with peripheral artery disease to iron reduction versus control. The treatment group underwent periodic phlebotomy, removing iron, to lower their ferritin, targeting about 25 nanograms per milliliter without inducing anemia, while controls received no iron removal. Over an average of about 4 years follow-up, ferritin levels were successfully lowered. So in the phlebotomy group, they had an average of about 80, and the control group had an average of about 122. The trial's primary endpoints, all-cause mortality and combined cardiovascular events, were not significantly reduced by iron reductions, though there was a trend towards fewer deaths. So that means that on the basis of this, there was no difference between the control group or those who were in the active arm of the group and were getting their iron taken off every month. Albeit, what I will say, this trial, interesting because it doesn't support the low iron hypothesis, but actually across the board, these ferritin levels aren't that high. They're not high enough, I think, this is my professional opinion, I guess, based on what I know, to really prove that having a lower iron is beneficial, because actually both of these groups tend to have sort of low iron if you consider that 250, 300, and 350 are often sort of high levels of ferritin that you do see. Anyway, there is also mechanistic support. So at the biochemical level, there's ample evidence links iron to processes underlying atherosclerosis. And I'm not going to go through the mechanisms, but just to show that, like, when we look at evidence, you look for mechanisms. So what happens in a cell culture? So we do find that iron does increase LDL oxidation at that mechanistic level. You look at epidemiology, so you see the association with higher iron levels and increased cardiovascular disease risk. But then, of course, you've got clinical trials. And the one clinical trial that's been designed to test this hypothesis did not find that association. But that is just cardiovascular disease. But what about cancer risk in iron levels? So there is a growing body of evidence to suggest that iron overload can contribute to cancer development, and conversely, lowering iron stores might reduce cancer risk. So iron can foster cancer through oxidative DNA damage, which leads to mutations, and by fueling rapid cell proliferation. Chronic hemochromatosis, so a genetic iron overload, is a striking example. Patients with hereditary hemochromatosis have a dramatically elevated incidence of liver cancer, especially if iron overload has caused cirrhosis. And studies show a 20 to 200-fold higher hepatic cancer risk in those patients compared to the general population. This illustrates iron's carcinogenic potential at high levels, and even moderate iron elevations have been linked to risk of certain cancers. So there is epidemiological studies have observed that high dietary iron, particularly from heme, which is red meat, that's the most bioavailable form, correlates with increased colorectal cancer, and prospective data indicate that individuals with higher ferritin levels tend to have higher long-term cancer incidence, though there are, of course, confounding factors, and this is just epidemiology. The cancer endpoint in the FEAST trial, the one that I was mentioning before, did actually find a significant difference in cancer outcomes between the iron reduction and control groups. So even though the trial was designed for cardiovascular endpoints, cancer incidence was tracked over that 4 years, and patients randomized to iron reduction had substantially fewer new cancers. 6% versus 9.4% in the control arm. So well, that's an interesting finding for sure. Among those patients who did develop cancer in this trial, the iron-reduced group had a much better survival. Cancer-specific mortality was less than half that of the control group, which is super interesting. And that's a published result in the Journal of the National Cancer Institute. Notably, the average ferritin during follow-up was around 80 nanograms, as I mentioned, in the iron reduction group versus 122. And the investigators reported that patients who remained cancer-free had a lower ferritin than those who developed cancer. So it does suggest a dose-response relationship where lower iron stores correlated with lower cancer risk. And there are some trials in animal models that echo this iron-cancer connection. And the consensus among proponents is that maintaining a lower normal ferritin could reduce longer-term cancer risk. So that's super interesting. And the FEAST study did really show some sort of like proof of concept with that. Now, is also information about immune function. So interestingly, proponents of low ferritin argue that reducing excess iron might protect against some infections by depriving bacteria of a growth element. So there is evidence that individuals with high iron stores are more prone to infections by certain bacteria. However, iron is required for immune competence, so iron deficiency can impair the body's ability to fight infections. Studies on iron deficient animals and humans show reduced ability to mount immune responses, really just showing that or suggesting that high iron stores can foster infection, but very low iron can weaken immune defenses. So again, I think this is really just pointing to having adequate iron stores and not necessarily having super low stores. So this does suggest that, there is, as with anything, sort of a fine line with how much iron is considered beneficial and how much may particularly be harmful. There may also be a relationship with neurodegenerative disease. So iron accumulation in the brain is increasingly recognized as a feature of aging in many neurodegenerative diseases. So unlike the blood, the brain is separated by the blood-brain barrier, and iron homeostasis in neural tissues is actually really tightly regulated. But with age, iron gradually builds up in certain brain regions, and excess iron in neurons in glial cells can generate oxidative stress. So this will contribute to those misfolding of proteins and neuronal death, which is characteristic of neurodegeneration. And postmortem and imaging studies have found iron deposits in the brain in Parkinson's disease and in the hippocampus and cortex in Alzheimer's disease. And what I will say is that neurons, they're highly metabolic and sensitive to oxidative damage. So, of course, excess iron can exacerbate the production of these reactive oxygen species in mitochondria and impact on the overall brain. So overall then, these are some of the reasons put towards why we'd want to consider having low iron across the board, across our lifetime, maintaining ferritin in that lower end of normal, around 20 to 30, reduced oxidative stress, cardiovascular protection, lower cancer risk, metabolic and liver health, neuroprotection, and possible longevity in aging benefits because of the role with mitochondria. But what about some risks of excessively low iron levels? Well, the first one obviously is iron deficiency anemia. So if you get overzealous about iron reduction, you do run the risk of developing that, and that will cause fatigue, weakness, impaired cognitive function, immune function, reduced exercise tolerance, and a ferritin below 15 is diagnostic of iron deficiency. You will have potentially an impaired immune response because iron is vital for immune cell proliferation. And if ferritin and another marker of iron transferrin saturation become too low, immune defenses can absolutely weaken. And iron deficiency is associated with reduced cytokine production and diminished antibody responses to vaccine. Diminished exercise and cognitive performance. Iron is required for making hemoglobin and enzymes in muscles and brain tissue. So athletes or very active individuals may notice reduced endurance and aerobic capacity if ferritin is too low. And it is reported that some endurance athletes feel best when ferritin is well above 20 nanograms per milliliter, perhaps around 50 to 100. That's absolutely my experience as well and my recommendations. And values below 30 can impair VO2 max and energy levels. Iron is also important for neurotransmitter synthesis like dopamine and myelination in the brain, and chronic low iron can lead to concentration difficulties, restless leg syndromes, and developmental issues in children. Therefore, there is a performance cognitive risk to having low iron stores, especially in vulnerable groups like young children, pregnant women, or athletes. And it is actually standard medical practice to ensure ferritin is above 50 in such groups to optimize function. Proponents of low ferritin hypothesis do not suggest letting ferritin drop into the teens in these populations, so they do advocate a careful balance, but the risk remains if managed improperly. And also misinterpretation or misdiagnoses. So ferritin is an acute phase protein that goes up in inflammation. So a risk of focusing on lower ferritin is that a high ferritin might be due to an underlying condition, such as infection, autoimmune flare, rather than an iron overload. So if one simply tries to lower ferritin without recognizing the cause, there is a danger of overlooking the real issue. However, keeping ferritin very low could mask that typical rise in ferritin that helps signal to clinicians that inflammation or infection is present. So there is a practical risk of diagnostic confusion, which underscores that iron management should be done under medical guidance with a full picture of the patient's health. Makes sense. And also, there is just a lack of proven benefit versus risk. So you might undergo phlebotomies or dietary restrictions to keep ferritin below 20, but there's no guaranteed benefit since the clinical evidence is certainly not definitive. There is an opportunity cost or effort that might be in vain if the hypothesized benefits don't materialize for that individual. So until there is data that confirms tangible outcome improvements, it's not clear that there's a real benefit to keeping your ferritin that low. And then, of course, what is the counter argument to keeping ferritin to 20 to 30? And I've already mentioned one of them is the experience of athletes, particularly when their ferritin is too low. But the key points from an opposing perspective is that there is inconsistent epidemiological evidence. So regardless of what you think about epidemiology, not all studies confirm that higher ferritin is harmful. In fact, several large population studies have found no clear association between moderately elevated ferritin and heart disease. For example, a prospective study in over 30,000 women reported that neither ferritin nor the transferrin receptor ferritin ratio was significantly linked to coronary heart disease. The initial positive findings from Finland, which I mentioned, where men with high ferritin had more heart attacks, were not replicated in US cohorts or other ethnic groups. And researchers note that Finnish diets in the 1980s were high in both iron and saturated fat, which might explain why iron appears as a risk factor there but not elsewhere. A meta-analysis of multiple studies yielded inconclusive results on the iron coronary heart disease hypothesis, with some studies even suggesting an opposite trend or protective effect. Such variability, even in epidemiology, does cast doubts on iron being a primary driver of cardiovascular disease risk across the board. So detractors argue that if low ferritin was truly broadly protective, epidemiology should consistently track and show lower heart or cancer risk in people with a ferritin below 50, but it doesn't uniformly do that. So that is sort of important because epidemiology ideally should form a basis from which hypotheses are developed. And in this instance, it was. And they did do that FEAST trial, and there were non-significant findings. So that's interesting. The fact that ferritin is an inflammation marker is confounding. So ferritin elevation often reflects inflammation or illness rather than just iron load. And this is another counter argument. So it goes up in response to cytokines during infections, inflammatory diseases, liver disease, metabolic syndrome, if you've had a hard training session, if you've had a lack of sleep, if cortisol was high. Like, there are a lot of things that affect your ferritin level. Therefore, people with high ferritin might be sicker due to some underlying inflammatory condition, which is the real cause of their heart disease or cancer risk, if I bring it back to that, and not the iron itself. So obesity and fatty liver can raise ferritin, and these conditions increase cardiovascular disease risk. However, when you adjust for markers of inflammation, that largely takes care of any link between ferritin and heart disease. So there's just no longer a relationship to be seen. Elevated ferritin in the context of diabetes or obesity might be a result of those diseases because of inflammation and liver stress rather than a cause. Critics highlight that in the FEAST trial, individuals with elevated inflammatory markers were excluded at baseline. Yet in real life, many with high ferritin have concurrent inflammation. So it's really hard to disentangle cause and effect. Is ferritin causing the disease, or is it merely a byproduct of the disease process? So skeptics lean towards the latter explanation in many cases, cautioning that lowering ferritin might not fix the underlying problem if inflammation remains, which is exactly what I said before. Clinical trial and genetic evidence against a benefit. Beyond epidemiology, interventional and genetic studies have raised challenges. Obviously, I've already mentioned the FEAST trial itself failed to show a statistically significant improvement in cardiovascular disease outcomes. More strikingly, there was a Mendelian randomization genetic study in 2017, which found that genetically higher iron status was associated with a lower risk of coronary artery disease. In that analysis, people with genetic variants that cause slightly increased iron levels, such as the HFE gene, had about a 6% reduced risk of coronary artery disease per standard deviation increase in iron markers. So the opposite has been found in these Mendelian randomization trials. And the authors concluded that higher iron might actually be protective for the heart. Now, just to tell you what a Mendelian randomization trial is, so Mendelian randomization is a way that scientists use people's genes, which are randomly passed down from their parents, to figure out if something like diet or exercise actually causes a disease instead of it just being linked by chance. Another counter-argument is the perspective of hematology and general medicine. So many experts in hematology point out that iron deficiency is a far more prevalent and concerning health condition rather than iron excess. They worry that enthusiasm for very low ferritin might lead to inadvertent iron deficiency in susceptible populations. From a clinical standpoint, a ferritin of about 50 is considered a healthy, sufficient iron store, not an excess that needs reduction. And in fact, common guidelines say that a ferritin between 50 or 100, you can basically exclude iron deficiency anemia. So experts who are skeptical of the low ferritin hypothesis believe that ferritin levels around that are not harmful, and they're typically safe for most people and provide a buffer of iron. And they do note that the reference range for ferritin is very wide, and there isn't consensus that the high end of normal confers excess risk. Although from what I see with people with high ferritin is that they can often feel quite sluggish and it's hard to do things, and they have like a redding of the skin. This is just sort of anecdotal. They have reddening of the skin and they just don't feel as good. So actually getting rid of iron, if you're up at around that 300 in ferritin, can actually be quite helpful. There are also alternative explanations for observations. Detractors suggest that lower heart disease risks in premenopausal women could be due to estrogen's protective effects, healthier HDL profiles, or even other factors. And I've got to say, this is my understanding as well, that it's not to do with iron levels. It's that estrogen is protective, and once estrogen drops, as it does when you go through menopause, you no longer have that protective effect. Likewise, the cancer reduction seen in the FEAST trial might have been influenced by unknown bias or the fact that patients with a recent malignancy were excluded, so both groups were relatively low cancer risk to start. And some statisticians note that cancer finding, while significant, was a secondary endpoint and the trial wasn't originally powered for it. So it actually needs to be confirmed by further randomized trials before changing clinical practice. Infection risk arguments can also cut both ways. Obviously, you don't want to be deficient, but you might not want to be too high. And in fact, targeting normal ferritin of about 50 to 100 is probably a good outcome there. So the critics' stance, and this is where I am as well, is that extreme iron overload is harmful, but I'm unconvinced that mildly elevated ferritin within a normal range is a significant driver of disease in otherwise healthy individuals. And in fact, and this is what I see as well, is that too low iron that is trending down well below that 50, is detrimental for cognitive function, for recovery from training, from actually getting the most out of your training. And this is athlete or not, like, you're a human, hopefully you're active, like, you want to make the most of that. And having ferritin levels too low, you really run the risk. And so when I have practitioners comment on posts I write about iron saying that's far too high and it's dangerous when I'm suggesting 50, I've really got to question, if this is the information they're using to make a claim like that, then I do have to question it, to be honest. So it's likely, and this makes sense, I'm sure, is that the relationship between iron and disease could be J-shaped. Both too high and too low could be detrimental. And what I will come back to and end on is never forget that your own personal experience with your iron level and to get it checked is super critical, because for someone, 30 might feel absolutely brilliant, and they may even be an athlete and that might feel great, whereas for someone else and a lot of people, that's just too low. So hopefully I don't think that was overly technical actually, but hopefully you get an idea of where this information of where our ferritin should be sort of sits, and you can make your own judgment, I suppose, based on some of the evidence here, but also just your own personal experience with what your ferritin's doing. Anyway, okay, so have a great week. You can catch me over on Instagram, Threads, and Twitter at Mikki Williden, Facebook at Mikki Williden Nutrition, or head to my website, mikkiwilliden.com, book a one-on-one call with me and we can discuss your ferritin levels if you like. All right, team, see you later.